We would now like to welcome our two distinguished keynote speakers. From MIT, we have Professor W. Eric L. Grimson, and from UC Berkeley, we have Professor Ronald Gronsky.
Ronald Gronsky 先生です。お二人の先生方にはそれぞれの大学の
And we will hear about what is happening at their universities concerning education strategies and systems.
I'd like to welcome our two distinguished keynote speakers, Professor Eric L. Grimson, Chancellor for Academic Advancement at MIT, and Professor Ronald Gronsky, Special Faculty Assistant to the Chancellor for International Relations at UC Berkeley. They will present on their university's education strategies and education systems. First, please allow me to introduce Professor Eric Grimson from MIT, whose presentation is titled An Insider's View of an MIT Education. まず MIT のグリムソン先生をご紹介いたします。拍手でお迎えください。
So please welcome Professor Grimson.
Thank you. And President Mishima, thank you for inviting me to join you at this wonderful event, where I think we will have some great discussions. I want to give you a sense of how MIT approaches education. I'm going to focus on undergraduate education. I know graduate education is important, but I'm going to focus on undergraduate education and give you a sense of how we think about the ways in which we're changing how we teach our students. I'd like to start with MIT's mission statement. This is a very long statement. There will not be a quiz at the end of the talk. You do not have to answer the questions on this statement. But I think it reflects what I heard from President Mishima about, in fact, I think what is the focus here at Tokyo Tech. And I want to highlight for you in particular this statement. MIT is committed to the generation, dissemination, and preservation of knowledge, and to working with others to bring this knowledge to bear on the world's great challenges. And these two pieces really reflect the way we think about teaching. We both create knowledge, but we use it to tackle important problems. And that means we both think about how do we transmit fundamental information, but how do we give students an opportunity to use it in natural, real-world contexts. So this very much influences the way we think about how we teach. Now, having said that, this says that our curriculum will look very similar to many other universities. Physics is physics. Chemistry is chemistry. We're going to teach that. But we think that as much learning happens outside the classroom as inside it. And that affects the way we think about teaching. And we also think that at least as much education is focused on non-technical skills as with technical ones. Communication, teamwork, leadership, mediation. These are talents that a student needs if they're going to be a leader in the future. And they are going to acquire that not in a classroom, but in activities outside the classroom. So learning in traditional settings is important, but so are these other elements. I'm going to tell you a little bit about MIT's current system and about how we're changing it. But let me start by just giving you a sense of MIT students. This is a busy slide, but I simply want to highlight for you that our students are certainly very strong technically. For those of you who know the American system, the average SAT scores are shown right here. They're very high. But what might surprise you on this slide is to notice some other things. Almost a quarter of our students who are admitted have won a national or international prize in academics. But equally, almost 20% of our students are athletes or musicians or artists at a technical school, which may sound surprising. So breadth of interest is very important as we think about what our students want to do. Now, where are our students? Well, I think similar to Tokyo Tech, We are primarily a science and engineering institution. 2/3 of our students major in engineering, another quarter major in science. Our two largest departments are electrical engineering and computer science and mechanical engineering. They account for 40% of all of our students. And in fact, much as I regret having to say it, that first bar there are almost all entirely computer science students. So at MIT, almost a quarter of all the undergraduates major in computer science. So it's a very technical school. Here's, however, what the students want to do. And students have changed from previous generations. So students certainly still want to get a very deep set of disciplinary knowledge. They want to know a lot about a discipline. But they want to learn it in real-world contexts. They don't want to simply do it in a standard classroom. And in particular, what we see is that they are very focused on learning how to use those skills to tackle a problem that does not belong to a discipline. We've often said that in previous generations, a student came to MIT wanting to be an X. What I mean by that is they said, I want to be an economist. I want to be a computer scientist. I want to be a physicist. Today, our students come to MIT saying instead, I want to have an impact on Y. I want to make an impact on energy, on the environment, on healthcare, on education. And this means we're changing the way we think about how we, in fact, educate our students, because they are much less likely to want to fit into a silo of a standard department. They're much more likely to want to take courses across many departments and tackle a problem. And finally, they are very interested in having an impact on a global stage. They understand that they may have the best idea in the world, but if they don't understand the context in which they wish to apply it, they don't understand the culture of the place in which they want to apply it, they will not succeed. And so they really want to have a global experience. With that said, those two words are really important as we think about how we teach our students. How do we do it in a context-driven setting? And how do we do it in a cross-disciplinary or multidisciplinary way? Now, our students at the same time are characterized by both being great at solving hard analytic problems, but also framing those problems, knowing how to ask the question as well as how to answer it. And you can see the other characteristics. I suspect they're much like students here. They're technically deep, they're context sensitive, globally aware, innovative, entrepreneurial, and they are the future leaders, so we really have to train them well. Because of this, MIT is changing the way it teaches in 4 major areas. We're thinking about new ways to deliver the content, primarily through online tools, and I will talk very briefly about that. But those tools are enabling more flexibility for the students as they design their own degree programs, and improves the learning in ways that we think really strengthen how we deal with it. So we're going to change the way we deliver. We also are changing the content. As I've already suggested, we think that content should be much more cross-disciplinary and not belonging to a standard department. We're also changing the settings in which we teach. This is a wonderful lecture hall, and my guess is 10 years from now, you won't use it, because it's a traditional, tiered lecture hall. And those of you sitting way up at the back, it's really easy for you to fall asleep. If you do, please snore quietly so you don't disturb me. And telling jokes in one language while translating into a second language is not a good idea, I know. But these halls are traditional halls. We're changing the way we think about how do we teach. What does a classroom look like? What does a living space look like for a student? And finally, we really want to focus on how to give our students global leadership skills. So let me show you what an MIT experience looks like. This is what we require of all of our students, and I want to start with a highlight. And the highlight is that we think it is very important for a student, no matter what major they have, no matter what department in which they belong, it is very important that they see different ways of thinking, different modes of thought. So every student at MIT, no matter what department they're in, must take 2 math courses, 2 physics courses, a chemistry course, and a biology course. So they can think a little bit like a physicist, like a chemist, like a biologist, like a mathematician. We also, though, require them to take 8 courses from humanities, arts, and social sciences, because we also think it's important that they have a good sense of how a humanist thinks about problems. Once the students have completed those general institute requirements, they take roughly half of their courses in a department. But this is where we're changing. And that is that whereas in the past those courses would have been just in that department, as you'll see shortly today, many of those departments require courses across disciplines, and they give the students flexibility as they decide how to deal with them. The third big change we've made is we have explicitly required students to take what we would call a communication-intensive course. So this is a course about how to communicate. In the first and second year, a student takes one of a small number of courses in the humanities, which makes sense. In the third and fourth year, students take communication-intensive courses in their major. So every department has to design courses about how to communicate as a mathematician, as a physicist, as a computer scientist. We think this is incredibly important for our students. If they have a great idea and they want to sell it somewhere, they need to be able to persuade you they have a great idea. And having them have explicit experience in communication, we think, really makes a big difference. As an example of one piece of curriculum, this is a computer science major. All I want you to see in this slide is the depth. That is, a student starts with a set of courses down here that are fundamental, some math courses, some introductory courses, but they then move through 5 different layers of depth so that they see topics in growing intensity as they move through. But up here, students have a great deal of choice. We let them select what is of most interest to them and design their own degree. This may bother some of you who think, but how can you say somebody's a computer scientist if they don't know programming languages or if they don't know compilers? Our view is if you take all the knowledge that every student should know, the average degree will be about 10 years in length. This is not a good idea. Rather, we want to give students enough information to know the basics and to know how to learn more when they need it, to do lifelong learning, if you like, as they move on. So how do we teach? And how do we structure our curriculum? Here I want to highlight that we have changed in the last few years to really focus on hands-on, real-world experiences. And I want to give you just one example. Our introductory course to electrical engineering and computer science, which is taken by about 80% of all students at MIT, has only 1 lecture a week, but it has a 1.5 hour software lab and 1 3-hour design lab. In those laboratories, the students are required to get a small mobile robot, as you see at the bottom here, to execute a task. So they have to make the robot do something. And this motivates learning the mathematics, the physics, the control, the programming that they need in order to make this happen. I know I have many engineers here. One of the first things we ask the students to do is to get the robot to simply run down a corridor without hitting any of the walls. The students think, this is easy. I would tell you that our walls of our laboratories are wrapped in bubble wrap because the robot constantly bangs into the walls because they haven't learned the control theory. But by showing them the problem in context, they suddenly realize why they need to know some mathematics. So we're changing the way we teach. It's hands-on, it's action-based. Students are required to get something to solve a particular task. Second thing I want to show you, though, is the things we teach outside the classroom. Communication, leadership, global experiences, research, and perhaps the last two will surprise you, athletics and arts, but they're important to us. I've already suggested communication, but let me show you an example of other places where students learn outside the classroom, and I'm going to do these fairly quickly.